Hello, everyone. Give me a thumbs up if you can hear me. We are here for another session of Community Conversations, our Technomatics virtual user group. And today's topic is deep dive exit strategies of active material flow elements. So as many of you know, my name is Taryn Blake. I am the Community Engagement Program Manager for our PLM community. And our speaker for today, as very often is Mr. Stefan Bongso. Stefan is a freelance simulation expert who has been in this space for decades. He's completed hundreds of projects and training sessions with more than 20 sessions for us here in the Siemens PLM community. Stefan has published 5 books on plant simulation, and he's one of the leading contributors to the community forums. And we're very happy to have him here again today. Our agenda, the big steps that he will talk through today on this tutorial, our exit strategy versus flow control, some basic strategies for this, and then strategies based on balancing material flow and successive production stages. And then lastly, visualizing the material flow using Sankey diagrams. So as always, we are live. These sessions are always live. Stefan's going to go through this in the software right here. If you have questions while he's going through, you can definitely put them in the chat and we'll review them at the end. When he finishes the presentation, you can also use the hand raise button for the live Q&A. So you can look on the top of your screen in the middle. You should be able to see that button. And if you have a question that you'd like to speak verbally, definitely we'll have plenty of time for that at the end. That is the end of my intro, and Stefan, feel free to steal the screen. Thanks.
Hello. Our today's topic is quite basic topic. It's the exit behavior of material flow elements. And I start with this means the decision you have to make if you have several successors like this. You have one source and you have, for instance, 3 different stations, and then you need to control or how to distribute the parts to the different successors. This is the question for the day. And plant simulation offers different ways to control the material flow here. And you have 3 different strategies. One strategy is the tab exit. And here you can define the exit strategy of this material flow elements. And you see here a lot of different ways you can do this. A second way, not for today, is to define the exit control. And if you define the exit control front, then you need to control the distribution of the parts to the different successors, because plant simulation then ignores all the settings you have done here in the exit tab. This you need to know. And so you need to you need to move finally the part in your method with, for instance, add.move. And a third variant, I want to show this first. This is from the history of plant simulation. There's the flow control. This comes from a time where the object itself doesn't have the exit strategy. And here you can find the same exit strategy and some exit strategy. And if you make if you compare this with the exit strategy of the basic objects, you will see, okay, the basic objects now have much more strategies than the old flow control. And the flow control is only available for the professional license. If you have a standard license or a foundation, then you don't have this flow control block. You can see this here, material flow. Here, the flow control is only available for the professional license. And so the flow control has one interesting exit behavior I want to show. I set my source to 60 seconds. And this you can find also cyclic, start at successor 1, random percentage, cyclic sequence. You have all this stuff also for all the material flow elements. But this one, to all successors, you don't have. This is only available here in the flow control. And what does it make? If you produce one MU, then it creates for each successor 1 MU. And so this behavior we have only through the flow control. More interesting for the flow control is the entry strategy, because you don't have entry strategies here for the material flow elements. And here you can define how to get the parts from the from the predecessors. And here we have several prepared strategies. If you don't have this flow control, you can use the pull control in the material flow elements and then create your own strategies for pulling the parts in the right order from the predecessors. Otherwise, for the basic strategies, you don't need the flow control. The material flow elements, the active material flow elements, all have one tab exit, and here you can and you need to set how you want to distribute the parts to several successors. Okay, and so I have prepared some examples, and the first example is, okay, how is the standard behavior? And I make some headlines here. And the first is replacement machine. First case should be you have a very basic material flow. You have a source, and you have 2 machines. One machine with 10 seconds cycle time, the second machine with 50 seconds cycle time for the same part. And the second should be a replacement machine. This means if the first station is out of order, have a break or a failure, then the second station should run. But normally the complete flow should run over the first machine. And so I activate here the failure. I set 90% with 5 minutes MTTR. And to have a look on the material flow, we can use the Sankey diagram. You find it in information flow in user interface. You have here the Sankey diagram. And you need to set, okay, what kind of MU you want to observe. Here it's MU's part. It's the basic part here. So I need to track the class of this MU onto the Sankey diagram. And okay, let's have a look. What's happened now? I set an end in this for my simulations here of 10 days. And let the simulation run until the end. And then I show the Sankey diagram. This already looks good here. Yeah, I don't have. Yes. So next, I want to see the statistical values of these stations. So I track a chart here into my frame and just track the stations on this frame on the chart. And yeah, I missed to set here in the source an interval of 10 seconds. Okay, and try it again. Okay, and this waiting portion of this first machine, it should not happen here. It should run over the first machine, and only if the first machine has a failure, the second machine should run. And so this the statistics should look different. And if I show the Sankey diagram, okay, it should be less here over the second machine. And so I need to change the basic behavior of plan simulation here. And this you make in the exit tab of the source here. The basic setting is here cyclic, and here is one option, blocking. If you don't set blocking, then plan simulation will look for the next available successor every time and move to this successor. Also, if you have defined some strategy. And so it's not the right. Cyclic means it starts first here, then the second, then again the first, and again the second. And so it distributes the MUs in a cyclic way here between these two successors. This one would be the right for this case. It should try to run on the first machine, and only if the first machine is not available, then it should use the second machine. And the result should be that the first machine is occupied almost 100% or has a utilization of 100%, less the 10% failed. So, okay, I apply this and I try this again. And now it's looked different. Now the first machine has complete here utilization is 90% and 110% is failed. And the second machine is only running for the half of its capacity. And so you need to be very, very carefully with your settings you make here, because it changes the utilization of the machines. Okay. Next example. You want to have, you need to add 5% scrap to your simulation, and the scrap should be marked and so we need here, for instance, the following strategy. Okay. Oh, I have a station. And at the end of the station, I need to mark 5% as scrap. And I need here a buffer and a drain. And now I connect first the drain, and then I connect the buffer and the buffer with the drain. Okay, to model this, we don't need to program. I need to program to mark this scrap as scrap. But here I can use also the exit strategy here, and there's an exit strategy, random. And here it's very important to blocking, because if it's scrap, it should go to the branch, to the scrap branch. Also, if here is a failure, then it needs to wait. And so if you want to ensure the order of this predecessors, the assignment should be also, if you have here a failure, then you need to activate blocking. Okay, then there's a list here. And the numbers here is the successor number. You can see this if you point your mouse pointer here to the connector. And this is number 1 successor, and this is number 2. Number 1 should be 95%, and number 2 should be 5%. And then it distributes the parts randomly between the 2 successors. And here I create a very simple entrance control. And I rename the scrap in scrap. Okay, let's have a test. We can see this here in the statistics of the drain, type statistics, the type statistics table. Okay, a part is almost 95% and scrap is 5%. If I select a longer time for the simulation duration, then it comes near to 5 and 95%. Okay, also you don't need one line SimTorque to distribute this in this way. You can also use this basic exit behavior to distribute parts depend on MU attributes. And one really basic use case for this is if you have, for instance, part E only on how many I have already? Station 6. If you need to distribute the parts by name, So very simple example here. I have a source and I need a table for my source to create a sequence. I want to have part E and part B. I want to have 5 part E and 1 part B in a sequence. And 10-second interval. Machines. And 1 train. Yes, this is part 6. And this is successor number 1. This is successor number 2. And here we can also use the exit strategy, should be blocking. So part E should go to station 6. And if station 6 is failed, then it should wait. It should be blocked here. And here you have mu attribute. You need to press apply first. And in the next step, you need to select the attribute type, the data type. And data type here is string, it's the name. And you can define a default successor. If you don't define the name here in the list, then it goes to the default successor. And open list, you need to specify the attribute. Attribute is name. And if the value is part E, then it should go to successor number 1. And if it's part B, then it should go to successor number 2. I want to visualize. I want to have a visualization here. I take again now 2 Sankey diagrams. One for part E and one for part B. And part E, it's here. If I open it in 3D, it's light blue. And so I change here the color to blue. And the Sankey diagram 2 is green. It's okay. And then I try this. Okay. This was not okay. So I need to check this again. Exit mu attribute. Oh, I don't have save my changes. So again, name. But here you can see, if you don't have specified here the values into this for the strategy, it all goes over the successor number 1. Okay, apply, and then let's try again. And now you have split the the material flow, all the blue bars are going over station 6 and all the green bars go over station 7. And you don't need one line of programming. And this you also can use if you, for instance, have a robot that loads a machine and have two different successors. And here you can also use this exit strategy, mu attribute, and the attribute you can use is previous location. The parts are remember the last location they had, and this you can use to select the right successor based on the previous location of the part. And this is also very, very simple. You don't need to program this. And so next example. Yeah, for this I need source. I take conveyor, a second conveyor. I need a drain. Station, and I need a pick and place robot. At the pick and place robot, I connect first with the conveyor, then it goes to the station. From the station, it goes back to the pick and place robot, and then it goes from the pick and place robot to the conveyor. And here I have two different successors. One successor is the conveyor 1, and one successor is here station 8. Okay, if I now start this, it blocks itself because the robot loads a second part and is not able to load and unload this station, and so I need to program an exit control for the first conveyor. The conveyor should wait, the part should wait until the robot is free and the station is empty. And so I need to wait. With this loading, you can check if the robot is moving toward somewhere empty to this place, for instance. And so it's better to catch also this case. And so I need to wait pick and place empty, pick and place doesn't load anything, and station 8 is also empty. And then I can move this part, and you can see it makes too fast. Okay, sometimes it moves also one part here to the next conveyor. And so to be safe, we can force this. By the exit control of this robot. It should also be MU attribute. And attribute type is here object. And then I open the list. The attribute I want to use is previous location. And if this is conveyor, then it should go to successor number 1. And if it's station 8, then it goes to successor number 2. And so you can force the pick and place to the right sequence. So one more example. And you can use the exit behavior, for instance, to control the distribution based on attributes of the successors. And I want to optimize the setup time. So if you want to do anything with setup time, then you need different MUs. I create again a sequence table. I want to have part E and part B. Sequence 5 part E and 1 part B should produce in a sequence, and I have 3 different. This is again 10 seconds. Okay, my example I have 12. Okay, I will keep it my example. 3 different stations. And I have different setup times here, for instance, 5 minutes. Second one, maybe 20 seconds. And the third one, 10 seconds. And I need a chart to see the effects here. I just okay, let's have a look. The exit behavior is still in the default settings, and I run this and I see, okay, station 10. I have a lot of setup time here in station 10. And now I can look here. There's some one way is here to distribute the parts to get a minimum setup time. Okay, let's have a look. And now it distributes the part in a way that we don't have to set up anymore, and so we can save a lot of setup time. And if I change another exit strategy, for instance, start at successor number 1, then it looks again quite different. Now I also use this station with the highest setup time, and I create a lot of setup time in this order of successors. And so you can use the exit behavior also to optimize your production distribution here. And you can use several statistical values, for instance, stat num in here for minimum contents, how long the station is already empty, and proc time, if you have different proc times for the same part, and so on. No line SymTalk. All is already built in here. Okay. One more example. Next example is assembly order. Oh. Okay, you have only one source. And this source produces both. This produces the container. One container. And then it creates parts. For instance, 4 parts. And the container should load 4 parts here. It's the basic settings. I have changed this. And then you want to assemble this using an assembly station. And one problem is we need here different predecessors. If we come with a connector, then we need different predecessors for the main part and the assembly parts. And so I use here a buffer in between, and then I connect first the assembly station, and then I connect the buffer and the buffer again with the assembly station. A short conveyor to see what happens. Okay, and now I need to send first the box here to the assembly station. I want to have assembly table based on predecessors. Predecessor number 2, I want to have 4 parts. Main MU come from predecessor 1, and I want to attach the MUs. And now I need to set up the source to send these parts in a fixed sequence. And also here, exit, blocking, important. And I want to have a cyclic sequence. Okay, and these are the successor numbers. First, it goes to one part, and then 4 parts to successor number 2. And this is the sequence. It can be more complex if you need it. And that's okay. I make here 1 second. And then you can see, okay, it works. Okay, we don't see here the assembly parts, but we can see in the statistics that it's going through this buffer. And so you can use this exit behavior also for this kind of and one last example. I guess you know the pick and place robot has its own behavior now, its own exit behavior since several versions of Plan Simulation. I have a conveyor, and here I create containers with a distance of 30 seconds. I have a source and the pick and place robot. You have here 3 different ways here to this. Yes, it's a different exit behavior. Just drag and drop the robot here onto the conveyor, and then you can select, okay, what you want to do. I want to load the part here on a MU on this conveyor. And if I now look at this, and then it's load part on the MU at sensor, and then all the other options are gone here. And so we don't need to program anything. And now the robot loads this container until it's full, and then it's over. Okay, a little bit longer today. So you can do a lot of different things using this tab, exit. And you don't need to program, and it's faster than your programming. If you try to do this with SimTorque, this is already compiled, and so this behavior is much faster than all you can do in SimTorque, and so you should look first into the basic default behavior of Plan Simulation if you can solve your problems with this. Okay. Any questions? chat. Okay. Can the exit tab be used with a dismantle station, or should a method? Depends on your version. Now the what was the dismantle station? The dismantle station has the difference is you have two different exiting MUs. You have maybe the main MU and all the parts on the main MU, and now you can you have a sequence MUs exiting independent of other MUs, and then you have a dismantle table, and here you can define what MU to which successor should go. And so you don't have the exit tab here, but you can use this strategy to distribute MUs to different successors. And the main MU you can define here, main MU to successor number 1. And if you have a lot of successors, you can define here in this table where the MUs should go. This you have since, I don't know, 2302, I guess. All other things you need to manage with the exit control, yes.
You should see on the screen the URL. You can actually click it to go there. This is where the recordings are posted. So this is the PLM community forums for Plant Simulation Virtual User Group. So at that URL, we post all of the recordings, all of the registration invites. When we make the new topic pages, we post the registration there. And let's see, the illustration or the GIF, the animated GIF that you see is showing you how to subscribe or follow the topic by clicking the follow button and then clicking the little envelope icon to select every post. So the only thing that we post in that area are topics from the series conducted by Stefan. There's a few sessions by Alex on these plant simulation topics using Technomatics. So it is a good way to get updates right away. If you select every post, you'll get a system message as soon as there's something new at that URL, including the recording, which will be there on Friday. My last announcement is just about the next sessions. You can also click those links if you are interested in seeing an overview of PlantSim 2504. That will be Alex doing that in 2 weeks. And then Stefan will be back for Perl chain optimization with a genetic algorithm. So a little bit more advanced topic, but you can register for either of those right now by clicking on those links. And what you're seeing on the screen right now is Stefan's contact information, including a link to his customer community profile. So over on the forums, that is how you can find him. You can mention him on these topic videos. And then also just a link again to the forum where the recording will be posted. So any final comments, Stefan?
If you have any suggestions for new topics for this series, then you can post this in the forum, and or you can contact me by mail. You'll find my contact. Okay, you'll find there my contact profile. Yes, and if you don't have any questions anymore, then thank you for the time, and see you next in 4 weeks.
Right, 4 weeks for you, but we will be here in 2 weeks if you're interested in that topic. And you've got some thank yous in the comments in the meeting chat. So Stefan, thank you once again.
Thank you.
Bye, everyone.